Today we're going to learn how to solve quadratic equations using the quadratic formula. This is the quadratic formula. It looks really complex, but as we get moving, calculator does a lot of work for us. It's not so bad. We can use this for anything in standard form. Remember, this is standard form. And we need it to equal 0. So all terms have to be on the same side. It has to equal 0. In this example, it's equal to 10x. So we have to do minus 10x on both sides. And it becomes x squared minus 10x minus 3 equals 0. It has to equal 0 just like when we factored. It can't equal anything else. Then we substitute in a, b, and c into the formula. So in this example, b is negative 10, so we put negative b, negative 10, plus or minus b squared minus 4ac all over 2a. So just taking those three numbers, a, b, and c, because a is 1, b is negative 10, and c is negative 3. Plugging those in to this formula and then simplifying. Our last step is to simplify. So when we put all of the, you can put all this in your calculator at the same time if you want to. It simplifies to 112, and the negative turned into a positive 10. 2 times 1 turned into 2. So that's where that simplifying step came from. We learned how to simplify radicals last class. So square root of 112 simplifies to 4 square roots of 7. And then the last step to simplify, we can actually do 10 divided by 2 to get 5. And 4 divided by 2 to get 2. So 5 plus or minus 2 square roots of 7 is our final answer. So let's try one out. This one, we have x squared plus 3x minus 10. Sometimes it helps to write a equals, b equals, and c equals. A is 1, b is 3, and c is negative 10. You don't have to take this step, but it does help sometimes. So we're going to substitute a, b, and c into our formula. Negative b plus or minus b squared minus 4ac all over 2a. This negative 3 plus or minus I'm going to leave alone. This, all of it underneath the square root, I can go ahead and put in my calculator together, or I can simplify using order of operations. That will give me 49. And on the bottom, 2 times 1 is 2. In this case, the discriminant, this underneath the square root, this is a perfect square. So I can simplify the square root of 49 is 7. And when I have all whole numbers here, I'm going to split this up. Negative 3 plus 7 over 2 and negative 3 minus 7 over 2. Because I have that plus or minus, it gives me two different answers. So I get x equals, this will be negative 3 plus 7 is 4. 4 divided by 2 is 2. Negative 3 minus 7 is negative 10 divided by 2 is negative 5. So that's my two solutions. Nice whole numbers. When this is a perfect square, we get whole number solutions. Sometimes it's not a perfect square. So in this example, again, I'm going to put a is 1, b is negative 6, c is 4. Notice these are both equal to 0, so I didn't have to do any steps like we did up here. It's just go ahead and jump right into the quadratic formula. Negative b, b's already negative, so I'm just going to put a positive. It's the opposite of b. Square root b squared minus 4ac all over 2a. Start by simplifying underneath the square root and multiplying the bottom. That's easy. 2 times 1. Put this in your calculator. I get 20. Now 20 is not a perfect square, so it's not going to be as nice as this one. But we can simplify the square root of 20. We learned this last class. Square root of 4 times the square root of 5, or 2 square roots of 5. So I put 6 plus or minus 2 square roots of 5 all over 2. 6 and 2 are both divisible by 2. I can go ahead and divide, just like we did here, 10 divided by 2 and 4 divided by 2. Leave the radical. We don't divide that part. 6 divided by 2 is 3, and 2 divided by 2 is 1, so I can just put nothing, because 1 square root of 5 is the same as just a square root of 5. X equals 3 plus or minus the square root of 5. This one is kind of similar to what happened up here in this example. This one, A equals 4, B is negative 20, C, we're not equal to 0, so I'm going to have to add the 7 over first. So this, if I add these together, C is going to be 25. That's really important. It has to be equal to 0. Then we plug into our quadratic formula. Again, my B is already negative, so instead of putting 2 negatives, I'm going to make it positive. And then we do B squared minus 4AC all over 2A. Always start by simplifying underneath the radical and doing the denominator. 2 times 4 is 8. When I simplify this, I get 0. The square root of 0 is just 0. So this is 20 plus or minus 0 over 8. If I do 20 plus 0 over 8 and 20 minus 0 over 8, I just get 20 over 8 on 20 over 8 twice. But we can simplify that to 5 over 2. They're both 5 over 2. Or you can put it as a decimal, 2.5. Either way, we're going to just get x equals the same solution twice. So we can just say either the fraction or the decimal, but they're the same thing. So when this is 0, we get the same solution twice. There should always be 2 solutions. We have 2 solutions. We have 2 solutions because of the plus or minus. We have 2 solutions that are the same. Or this last one's going to be just a little bit weird. Again, we're not equal to 0, so I'm going to have to subtract 5 from both sides first. Alright, so this one we get A equals negative 1, B equals 4, and C equals negative 5 after I bring that over to equal 0. Negative B plus or minus the square root B squared minus 4AC all over 2A. Go ahead and simplify. This underneath the square root is going to give me negative 4. The square root of negatives, we talked about this last class as well. I cannot take the square root of a negative number. That is imaginary. So once I see that, I don't have to worry about simplifying anything else. I just stop and I say the solutions are imaginary and we are done. I don't need to do anything else. So we sometimes when we use the quadratic formula, we get 2 nice solutions. We get 2 solutions where there's still a radical. We get 2 of the same solution, or we get imaginary. If we can't simplify the fraction, for example, if I had 5 plus or minus 3 square roots of 2 all over 2, if I cannot divide these nicely, just leave your answer as a big fraction. So sometimes we can simplify to have this, and sometimes we leave our answer as a big fraction.